Okay, I will take that as a resounding no. Just to remind you guys one more time, homework is primarily for getting practice. If you're finding yourself getting behind in homework, let go of checking off the box. Homework is supposed to be more than just checking a box off. So if you cannot do every problem, do like young Jeff did and don't. Don't do every problem. Then the teachers that didn't work with me about that I made less than optimal grades. I kicked ass on the test, but my homework grades were always kind of rough. So I was working my stupid ass off, trying to afford going to college. You guys kind of, so I understand. We all have situations. I get it. So you work within what I ask for in terms of what practically makes sense for you. You guys with me? That's what you should do in every class. No matter what the teacher says, you make it your own. Yes. Okay. So you want to be up to date with this homework. So especially with what I'm about to say. On Monday, we're gonna have a quiz. We have a quiz on 4.9 and 5.1. I like it. Come back to me. Come back to me. There you go. And then because we can't just have one, we're gonna have a quiz on Wednesday. 5.2 and 5.3. Make sure. Yeah. Yeah. So ready with me. So 5.1 was, 4.9 is antiderivatives. 5.1 was Riemann sums, where you get the rectangles, finite number of rectangles. 5.2 is where we up that to infinite. We do the fundamental theorems, yes, if I remember correctly. And then 5.3, let me double check. Oh, no, 5.3 is the fundamental theorem. 5.2 is where we do infinite rectangles, yes. Okay. So everybody with me. So we have 2 quizzes next week. Our next test, believe it or not, is December 3rd. I can't believe it's already freaking almost December. And I hate all the Christmas things I see. I love Christmas, don't get me wrong. But Christmas should be in its own month. Keep it special. But we have different opinions. But you can do well. So anything about that? You guys with me on it? So quizzes next week? Okay. Okay. So let's do this. I want you guys to give these a try. If you've already done this, then stop overachieving. Come back. If anybody just came in and does not have the sheet, let me know. Does everybody have the sheet? Okay. So go for it. Give it a try. So number 1 is a beautiful review for the quiz coming up on Monday. Just antiderivatives. You got that sheet, right? Yeah. Alvaro? Yeah. Do. Okay, so this very first one is just a direct application of one of the few integral rules that we have. So integrals normally are just undo the derivative somebody did, right? One rule we can develop, because it's a very basic equate a function, is x to the n. So x to the n kicks ass for derivatives. So we're kind of hoping they should relatively kick ass for intervals then. Right now, of course, the absolute best function ever is e to the x. What's the interval of e to the x dx?
E to the x.
E to the x, cool. So, plus c.
Plus c.
Let me make this really clear. I'm kind of surprised I haven't done this yet. These together, both of those are the symbol. This is the first time we've ever seen a function that is basically like bookends. Do you guys know what bookends are? If you have a bunch of books and you don't want them to fall over, you buy these things that look like little forklifts that shove underneath the book and keep them up. So this is bookends. This tells me what the variable is. If anybody's going to Calc 3, this is going to become stupid important because you're going to have a bunch of variables in here and you're going to want to know, well, which one am I looking at? And thank God there's going to be something here telling you. You guys with me? And then this one is important. We'll see in a minute. I got to know what the variable is to be able to answer that correctly. So you don't have to do a damn thing with this, not yet. Right now, this is just telling me what I'm taking the antiderivative with respect to. Okay. Does that make sense? So this together makes the symbol, makes the, like a square root symbol is one thing. These together are one symbol. They mean take the interval. Okay, maybe you guys are with me. So, what is the rule for x to the n? Yes. So it's the exact opposite of the derivative rule, like it's supposed to be, because intervals are supposed to be the opposite of derivatives. So with the derivative, I multiply by the old power and then make the old power go down by 1. With antiderivatives, I make the power go up by 1 and I divide by the new power. Everything's backwards. Do you guys see that? Which is beautiful. It's supposed to be. They're like inverse operations. So what's the integral of x to the negative 2? What's the new power going to be? Negative 1. And then I divide by it, which really just means in this case, make it negative, right? Divided by negative 1. Is that cool? So x to the negative 3 would become x to the negative 2 divided by negative 2. Yes? Okay. Don't know why I'm always 50. And then what's the integral of negative 3? Where would negative 3 come from? Negative 3x. Cool. Now, what we just did right there is crazy important. Doesn't matter what number I would have put here, would that have changed a lot? What if I put a 7, plus 7? What would I put here? Holy, what if I would have put a plus square root of 2? Plus square root of 2x. You guys follow? Good job, Jeff. So what if I put a pi? Pi t. You guys with me? Yes. Pi is just a number. Don't let it freak you out. It's just a stupid number. I don't want to write all the numbers. It'd take forever. So we just keep it all compact. Put it all into a pie. Bake it up. Give it some time. And then you get this. How do you always check yourself when you do an integral? Take a derivative. And derivative will almost always be easier. Now, I'm going to say this so many times, and some of you guys are going to get sick of me, and some of you guys are never going to quite listen. Quotients for derivatives are kind of gross. Integrals don't have a quotient rule. They don't. If I took this guy's derivative instead, could I just do secant squared theta over secant theta t? Could I just do the derivative of the top divided by the derivative of the bottom? Is that, think about it. If I take the derivative of a quotient, is that the derivative of the top divided by the derivative of the bottom? Is that the rule? Shit, no. So why in the world would the integral work that way if the derivative can't even work that way? Do you guys understand what I'm saying? So not to say integration is horribly difficult and nobody ever gets it. That's not what I'm about to say. Integration is almost always harder than differentiation. So if derivatives can't even do something straightforward, integration definitely can't. Because it's trying to undo what derivatives did. Does that make any sense? So we do not have a quotient rule for integration. We don't. We don't have a product rule. We don't have a chain rule. We have operations that try to undo those things. And we're going to learn about the way to undo a chain rule today. Right. That's the one thing we learned on top of just straight. And then all of chapter 7 in Calc 2 is going to be learning a lot of different methods for other things. Okay. So what do I do with this problem then? This sucks. Simplify. How do I simplify this thing?
Sine over cosine.
Yeah, so tangent sine theta over cosine theta.
Or 1 over cosine theta.
So what's the same on the top of the bottom?
Cosine.
Almost. Over cosine. So the over cosine cancels, yes? The top has an over cosine. The bottom has an over cosine. So of course the over cosines cancel. Be really careful. If this was just cosine on the bottom, these would not cancel, yes? Because one would have a cosine and the other one would have an over cosine. Are those the same? So of course they wouldn't cancel, yes? We get so freaked out, and I don't blame you because you don't get to work with complex fractions much, which just means fracception, right? Fractions inside of fractions. So these die. So then what am I integrating? Sine theta. What's the integral of that? Good, negative cosine theta. The trick to that is you write cosine, you think the derivative of cosine is negative, there was no negative, I better put a negative. Right? Because the sine cosine thing is a weird example of learning how to drive manual and you forget which way you're going, forward or backward.
So if you would
Yes.
have took the bottom and then flipped it around,
Oh yeah. Sine theta over cosine theta times the reciprocal of 1 over cosine, and
that
then
gives
the
you
cosine
the
cancel.
sine, and then you do the antiderivative.
Yeah. You'll get the
That's
same
how I
place.
did it, but
yeah,
I
you're,
was right.
That's beautiful. When you divide by a fraction, you multiply by its reciprocal, cosines cancel, kick ass. All right, how are those first three? Okay. Part D, how many terms are on the bottom of part D? 1. Whenever the bottom is a monomial, a one-term dude, you just break the shit up, because I'm allowed to. What is every piece of the top being divided by? Okay, good. So then just write it one at a time. So we get, because again, I do not have a quotient rule for integration. I don't have a way to do this directly. Even derivative can't do this directly. You have the rule for it, right? Okay. So this will be x to the 7/3 divided by x squared minus 4x divided by x squared plus 2 over x squared. So this will be 7/3 minus 6/3 is 1/3, 4 over x, and then this one I'm going to write like this. So the one place, by the way, this does not work. What's the one value of n this does not work for? Very obviously. -1. N can't be -1 for that rule, because if it was -1 like it is here, wouldn't this be x to the -1? We already know the answer to that. We know whose derivative is that. So let's see, let's do this one at a time. I can use the x to the n rule here because that's not -1. So what does this become? X to the, yeah, add 1. So 1 plus 3 is 4, put it back over 3. And then I divide by 4/3, which means multiply by the reciprocal. So how do I integrate? X to any power except -1. You add 1 to the power and you divide by the new power. So I always write the power first and then I divide by whatever I just wrote. And of course if it's a fraction, I just multiply by its reciprocal. Yes? Okay. Ain't no damn reason to write divided by 4/3. Ain't no damn reason to write that. That is just 3/4. And then this one, it's got a constant for constants. Do not let them trouble us. We don't give the first shit about them. They've come for the ride. That 4 comes for the ride. What's the integral, what's the antiderivative of 1 over x? Natural log of? Absolute value of x, yes. So this is 4 times natural log of the absolute value of x. Very easy to forget the absolute value. That I tried when we first learned derivatives, I pointed out that you want to match the domain. In the original function, can the x be negative? Come on, think about it. Don't listen to the question and you guess. Just think about it. Can the x be negative? Of course it can, right? If I don't put absolute values, could the x be negative in what I'm writing? No. So the domains don't match. So this has to have an absolute value. Okay. In fact, there was a problem here, over there. I think it's the problem that's right there. We did last time, and if I didn't have the absolute value, I wouldn't be able to do it. Poor little guy. And then how do I do this one? Yeah, so the power becomes -1, and then I divide by it. Good. Good. Okay. And again, if you have time, it should be relatively quick. You can check yourself. You can take the derivative, make sure you get back to the simplified version. Yes. Yes.
One slight question. I'm a little confused how you get x to the power of
Do it again. Sorry.
with like like up there, like x not up there. No little x. Yeah, that.
Yes.
Figure how you get x divided by 3 into the exponent.
No, it's 7.
Oh, that's okay. That makes more sense.
Yes.
I was really confused. It looks like. Yeah, that makes more sense.
Okay.
Yeah, that's.
Okay. Well, if you do it, you'll see from context this is definitely a 7. Okay. How's that one? Is that one all right? Yes. I'm sorry. Go ahead.
Could you, in another case, could you take the x squared and bring it up and make it a negative x?
Okay. So very
Or is
quickly,
that
I want to make sure. Some people think that some nifty magic happens if you do that. So let's see. So if I do this. Oh no, let me do this. Yeah. Integral x to the 7/3 minus 4x plus 2, and you just brought up an x to the -2, yes? Like that, yes? Okay, what would you do next? Can you integrate this? If I wanted to take this guy's derivative instead of integral, what would I have to use? If I leave it like this? Not chain, product, yes? Do I have a product rule for integration? No. So this doesn't help me. But people talk themselves into this helping them. Right? But if you think for a second, if this was a derivative, it would require a product rule. I'm integrating it, and integrals don't have a product rule. There must be something else I could do, because I cannot currently do this. And then you could just distribute this and get the same thing we just got, right? Because you would subtract 2 from a repower, which is what we did. Good. Not a bad thought, because you want to simplify or rewrite, but this doesn't really get us somewhere. Yeah.
Thank you.
Okay, and it's a good question because I see this a lot, and then people do stuff. I'm like, no. Okay, maybe. Does everybody really hear what I said? If you have an integral of a product, you're screwed. You have to rewrite it. If you have the integral of a quotient, you're a little screwed, unless it's a nice quotient, and I'll show you in a minute. The integral of 1 over x is easy. Does everybody agree? And that is a quotient, yes? So some quotients you could do if they're in a simple form that relates directly to another function, like natural log. What can I do for part E?
Give you what we did last time.
Do what?
No, it's not on it.
Can I split it up?
I don't know that would work because you'd be dividing 2x by like x squared minus 5x plus.
Yes, you'd have to divide each piece, and that doesn't do shit for
Yeah, that
us.
does not help.
It doesn't do shit for us. How many terms on the bottom?
3.
So you cannot split it up the same way we just did. It only works if it's a mono. Now you could split up
Factor.
2x over all that shit minus 4 over all that shit and then just stare at it.
Do x
Because
plus.
it doesn't, do you guys see what I'm saying?
Yeah.
So if it's a one term dude and I split it up, I can simplify each piece.
Simplify.
If it's more than one term, I'm screwed. But if I leave it, what can I do? Factor, yes. Whenever you see a rational function like this and you got polynomial kind of parts, you should immediately think factor. Later today, we're gonna have a second thing we can consider. But thankfully, Jeff decided to be nice and gave you an integral we can do now. How do I factor the top? And then how do I factor Bob? Bottom. Yeah, -2. And thankfully, what happens?
Get rid of one X.
Die. Okay. And then I got this. And then you say, all right, Jeff Math Boy, that is your name. You just told me I can't do quotient, Mr. Man. But what is the derivative of, for example, what is the derivative of the natural log of x minus 5? 1 over x minus 5. Yes? So what is the integral of 1 over x minus 5? ln of x minus 5. Well, let's make it official. Plus c. Yes? I need you, now real quick, I need you to be with me on this. This is almost, let me actually devote a little bit of time to this idea. That would be a nice change, Jeff. What is the integral of the sine of x?
Negative cosine.
Good, negative cosine x. Yes? Yes? So what is the integral of the sine of x minus 2?
Negative cosine X minus 2.
Why does that not screw me up? Because if I do this, do I need chain rule? Not really, because what's the derivative of this? 1. So if my function has an inside whose derivative is 1, it's almost as if it was just x. What's the integral of 1 over x? Natural log of the absolute value of x. What's the integral of 1 over x plus 11? The natural log of x plus 11. Right? I need you to see this. Now what this leads to, though, is students doing this kind of thing. All right, I need to quash this now, right? Put a big old no.
Yeah.
Big old no goes there, yes? How do you check this? You guys see the logic. In fact, some of you guys might be like, what do you mean, Jeff?
Bring that 2 down, it changes it.
You're making a mistake.
So what's this guy's derivative involve?
Well, yeah, that's not.
Negative 2.
Chain rule, yeah? So what should be right there in order for this integral to be easy? There would have to be a 2x here, correct? You guys see that? Because then it would be directly the derivative of something. So we currently, in fact, to just tell you directly, we're not going to have a damn way to do this by the end of this class. This is a Calc 2 problem.
Oh, okay. I was wondering about that.
Now, to be really honest,
Wasn't that the trick one?
yes, which is a Calc 2 idea. To be really, 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 really honest, there's an idea called partial fractions that not everybody learns, and that they will discuss in Calc 2. So most of the time, we used to teach partial. Anybody ever heard of partial fractions? And you're like, are you asking if I'm partial with fractions? No. It's a way to break this up into 2 different fractions.
That makes sense.
And then I can integrate each piece.
Yeah.
But most of us probably don't know that because we don't teach it as much in pre-calc anymore, which makes me sad. But if you're going to take Calc 2, they will go over partial fractions, and then you'll be able to do this. So it's still a Calc 2 idea. So everybody, I really want you guys with me on this. Dear God, the minute I start talking about ln, everything that looks like 1 over something becomes ln. And I'm like, no. Right, what's the integral of 1 over sine? Is that ln? Is this right? Because what's the derivative of this? It would be 1 over sine times
Cosine.
cosine. So no. What is the one definitive time that I could just directly make it a natural log if the bottom has a coefficient of 1 and a power of 1? X plus 2. X minus 7. Are you guys
Yeah.
with me? Otherwise, it's a chain rule, and you would need the chain rule piece to be. Okay, we're going to focus more on that here in a bit, but I just want to lay that down right now. Okay. So, does anyone see what this might be? just to remind you guys, I could take that 2 out. That's something I focused on last time. Because what's this symbol mean? What's that integral symbol mean? More fundamentally. Say again? Even more fundamentally, just what is this symbol? Where do they get it from? Sum, yes. So if I'm adding a bunch of shit up and every term has a 2 in it, can't I just factor a 2 out? So what am I allowed to take out and put into an integral? A constant. Yes? What is x doing? Isn't x changing? Isn't that what this means? X is changing as x changes, right? So I can't take this out. I can never take a variable that is what my integral wants me to look at. I can't take it out and in. I can take constants all day long. That's why we don't care about them. You guys good? Yeah. Okay. So can somebody just tell me what the integral of 1 over x plus 3 is? Yes. Plus c.
It will be negative, right?
Huh?
It's minus.
No. Oh, it should be from the beginning. Yes. Beep. 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 Okay. Okay. That's the neat thing about teaching. You have these high ideas and you're like, oh yeah, it should be a minus. These were all indefinite intervals. And again, they just mean antiderivative. If you can simplify the damn thing, you do. Almost always. Okay. So I'm almost certain not all of us got down to here. But the first step on every single one of these is what? If there's nothing to simplify, what's the first step?
Plug in.
No, hell no, no. Mm-mm. Take the antiderivative. This has got to mean something. I've already got a way to plug shit in. I say f of x is this, and I go, what's f of 3? I already have a way to do that. Why would we have this symbol here? The symbol means, now more practically and specifically, it means antiderivative. Yes? Yes. Yes, exactly.
We can just take the derivative of that bit.
Yeah.
Like, use the 2 e and a values to
Yes.
figure out.
And just to remind you guys, even though I like to say big ass F, and it does sound like something I would have made up, it is the official way we represent antiderivatives, yes? You're not going to see a math book that says big ass F, but that's what I like to call it. Okay, so somebody help me out. This should be really, 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 really nice. I just focus all my attention on the antiderivative first. So what is the antiderivative of 3x squared?
X cubed.
Do you see how that 3 just kind of goes back up? Or you could do 3, add 1 to the power, divide by the new power, but you guys see how you don't have to do that?
Yeah.
Either way you do it, you get x cubed. What's the integral of 1? That's crazy. And then I want to evaluate from, does everyone see how, if I put numbers on the integral symbol, it's just one more kind of step. Integral symbol means find the antiderivative. That's what it practically means.
Wait, wait.
Do it again.
Oh, wait, Alright, sorry, I was just looking at, I don't know when you put the.
Does everybody remember what this is all about?
Alright, what is that called again?
Doesn't have a name. It's just evaluate from -1 to 3. What number do I put in first? I don't know. Some of you guys are looking at me like this right now.
The 3. B.
Yeah. You put the 3 in first. And then you subtract what you get when you put the -1 in. So you put the 3 in. That's f of b, big S f of b, minus, put the -1 in. Big S f of b minus big S f of a. Is everybody with me? This is almost too nice to believe, really. Especially after going through 5.2 and doing all the sum of I squared, blah, 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 you know, it all boils down to this, yes.
Sorry, for these ones, we don't do the constant.
Oh, I did several examples with you, and I should have really pointed this out. Every time we did an example, we did put the plus c's, and do you remember how they just canceled every time?
Oh,
Isn't f going to have a plus c? So big ass f of b would have a plus c. minus big X f of A would have a plus C. They're always gonna cancel. Now, the one bad part about that is, I'm never gonna write the plus C, because I know I don't for the definite. I'm not even gonna think about it. So when I have a definite integral, I know the plus C's cancel. What sucks about that is, it leads into you forgetting you need a plus C with the indefinite, yes. Okay, I like it. Or people put numbers and they put plus C at the end. I'm like, no. No, this is gonna be a definite answer, yes. So what is this? This is 30 minus -1 minus 1, -2, so I get 32. Yes? Is that okay? Okay. So every single definite integral problem, the first step is just do the antiderivative. Now, the real first step is simplify, you can't. None of these you can simplify. I don't know why I didn't put one like that. So is everybody cool with part A? Alright, go ahead and try part B if you haven't done it yet. Did I start to? I did. It's amazing. By the way, if you've missed either of the last couple classes, dear God, you want to watch those videos, or come see me. I mean, there's a lot that you've missed. It was very, very bad classes to have to miss. So, good luck. Good thing I record my lectures. I really don't know why more of my colleagues don't do it. So just to point this out, obviously, if I give you a problem like this, I'm gonna say I want the exact answer. So even if you have a calculator with you, I don't give a shit. Right? I need the exact answer. So if you've forgotten what like stuff like cosine of pi over 3, you really want to memorize yourself. This one is nice though. I mean, I won't be able to tell because the exact answer is nice. What is the integral of, what's the antiderivative of secant squared?
Tangent.
Tangent. How did you figure that out? Why is that a silly question I just asked? Because what is this really asking? Just what function has a derivative that is secant squared? And you know that's tangent because you have the derivatives memorized. Yeah? So either an integral is just directly taking you back to a function, or I need a method to help me. We're only going to learn one method in this class above straight, and like this one is a straight integral. It's just exactly coming from tangent. So if I undo the derivative, it's just directly tangent. You guys see what I'm saying? Okay. So the antiderivative is tangent, and then I'm going from 0 to pi over 4. So what's the tangent of pi over 4?
Square root 2 over 2.
No, that's the sine or cosine of pi over 4.
It'll be 1.
Yeah, it's 1. So tangent, sine over cosine. Sine and cosine are the same at pi over 4. They're both right 2 over 2, so right 2 over 2 divided by right 2 over 2 is 1. So since the tangent's the ratio of sine and cosine, wherever they are equal, it comes out to be 1. And they're equal at pi over 4 and 5 pi over 4. If everything I just said was like Greek, even beyond the fact that I'm using a Greek letter in it, you better go freaking get some refresher or like learn trig very quickly. So just to remind you, if you got into this class and you never took trig, oh my God, I'm sorry. You are going to want to, I don't know if I haven't made that a big enough point before today, that's my fault, but I think I did. You have got to know trig. If you're going to take Calc 2, the entire chapter 7 just about. A lot of chapter 7 is trig. Deep trig. Okay. What about this guy? Oh, we did this guy. So if you weren't here, we need the absolute value there, because otherwise I can't solve it, blah, blah, blah. So we did that last time. Okay. Now look at part D. Just gaze at it.
So it's either there.
Nope, don't have to do that. So, watch this, guys. What is the derivative of 3 to the x?
X.
3 to the x
Oh, either.
times
One.
natural log of 3. Alright, now why did I do that? Do you all agree that any number to an x, its derivative has itself in it? So I know that this answer, this antiderivative, has to have this in it. Has to. So then I go, okay, let me check. Let me see what I'm missing. Am I missing something? Let me take this guy's derivative. This guy's derivative is this. So what's the antiderivative of this? This. Done. So if this wasn't here, let's do that. If the problem had been this instead, Jeff, try again. There we go. If the problem had been that instead, I would have put 3 to the x down, and then I would have said, oh shit, I must be wrong, because what's the derivative of this? 3 to the x times natural log of 3. Is there a natural log of 3 here? No. Does this make sense? I would then have to, all right, let me stop for a second. If I see 3 to the x inside, I know the answer has to have 3 to the x in it, because its derivative is itself, basically, with a little adjustment, yes? Anything to the x power is itself with an adjustment. Why is this not true? Why is this not correct yet? Because the derivative of this is not that. It's that times ln 3, yes? So what must have been here so that when I take the derivative, ln 3 would cancel? There must have been an ln 3 where? On the bottom. So I lay a little trap. That's the way I like to look at it. I'm going to lay a little trap on this guy. So when I take the derivative and the ln 3 pops out, it dies. So this feels like cheating in a way. But when you're integrating something directly, you are trying to make it match where this guy's derivative would become that. You are allowed to construct what you need. Let me show you one more example like this. What's the integral of sine 2x? Well, it's got to be this, yes? It's got to be something like this. Y'all agree? But I know it's not right. How do I know this is not, do y'all agree that it's got to be, that's got to be a part of the answer?
Yeah.
Because the derivative of negative cosine is sine, yes? Why is it not the answer though? Because what's the derivative of this whole thing? It'd be sine 2x times 2. And is there a 2 over there? Is there a 2 out here? You guys with me? So then what do I have to do here so that when the 2 pops out because of chain rule, it immediately dies? Divide by 2. Do you guys get the idea? Do you guys get the idea? Bam! That's the right answer. On one level, I understand. That feels like you're cheating. And I guess, I don't know if that does it feel like you're cheating. I don't know how it feels to you, but I know it feels weird. But what you're doing is you're constructing what the function must be so that its derivative becomes what you had in the first place. It doesn't exist yet. We're trying to figure out what it is. So I'm completely allowed to do that shit. Is that a true statement now? Is that statement true? Yes, so who cares how I got the 2 there? How did we get it there? We're like, there's no 2 there, so it must have died. Right? We're like little detectives. Well, there must have been a 2 sitting outside his house, so when he came out, he died. Right? I don't know why. Something like that. Oh, Your Honor, I'm just a poor son of lawyer. Okay. Maybe? All right, one more. What's the integral of e to the 11x? What must the answer have in it? But when I take this guy's derivative, it's itself times 11. There is no 11. It must have died on the way. Do you start to get a general pattern? You start to see. Okay. Made it. So when the inside function is linear, I'm just gonna have to adjust the number. When the inside function is linear, I just have to adjust the constant. We're gonna learn a method today that will apply to these, but it's gonna make it worse than it needs to be. That's why I like to show you this right now. But I am gonna show you a method where this kind of comes out in the wash. Okay. So then we figured out that this is the right answer. And I want to evaluate from 2 to 3, so then I just got to throw those things in there. So you got 27 minus 9 is 18. Is that okay? Yes.
I thought you said this was supposed to be over natural.
No. If this hadn't been here, I did a different problem where that wasn't there. But that is there, so this guy's derivative is that. So this guy's antiderivative is that. And now I can just plug shit in. Good. Okay. Look at part E. It's like I set you up for this shit. Can you guys just do this antiderivative directly? What's the answer gotta have in it? But there's no 3 here, right?
You gotta put 3 underneath.
Yeah.
And plug in that.
Now, I know it doesn't seem fair sometimes because we're about to do something that requires you know the properties of logarithms, but oh well. When we're in calculus, you have to know everything before. I'm sorry, that's just the way it is. If you forgot some shit, let me know. We can go over it. If I throw this stuff in, over 3. Does anyone know how to do that?
The weight cancels.
But 3's in the way. 3's in the way.
So you get
Right? These want to kill each other, but isn't that in the way?
You put it back in.
Yeah, get it out of the way. Properties of logs. What can I do with a coefficient of a log?
put it back in.
Put it inside as a power. Then these kill each other. What's 3 cubed? 27 divided by 3 is 9. What's 2 cubed?
That's 8.
8 divided by 3, right? And then whatever the shit that is, it's 19 thirds. It's alright.
19 thirds.
Yeah. So yes, you do have to know little things like properties of logs. I mean, it could show up anytime it wants. You have to know that factor, you have to know all this stuff. It's crazy. How you guys feeling? So I told you when we hit 4-9, the better you know derivatives, the easier antiderivatives are. Then we went through this weird trip down freaking find the area lane, right? We're like, holy shit. Then we proved that the area under a curve is directly related to the antiderivative. And we all should have celebrated because that kicks so much ass. Because the antiderivative is relatively easy a decent amount of the time. Definitely easier than sum of I squared and sum of I cubed and all that kind of shit. Yes? Hell yeah. Okay. I mean, I love that shit, but I don't want to do a lot of that. Kidding me? Okay. So let's do this. Any questions on these problems we just did?
Where'd the 8 thirds come from?
Oh, brought the 3 up as a power. ln and the e cancel. 2 cubed is 8 over 3. Anything else from these? So let's take a break now. Come back at 5 till. and then we'll do section 5.5.
Which one's considered manner?
This one's considered.
Oh, I'm working this problem that I missed on Monday. So
Oh, no. We're about to get into this.
Oh.
Yeah. I mean, we just did the other. I gave that out like right at the end of class.
Oh, okay.
Yeah. So, guys, can you please do those 3 problems? I'll stand here and stare at you.
Somebody's director wanted to do something. This is 5.5.
Yes. I never finished the. It's definitely never been the thing. I didn't finish the last. It got very heavy politics and such. I don't know if you ever watched the.
I've only watched parts of the, I've only watched the first season.
But did you read that? Okay. It does make for a decent show. It's definitely cheer people up.
Yeah, no, I definitely get some weird looks when I read this.
So you just came in, we're doing these here. You guys see how every single one of these is basically the same thing? The details are different, but the overall form is the same, right? So let me catch up to you a little bit. If I want to do the derivative of this, it's stuff to the 9th power. 9 is the outside power, right? The 9th power is the outside function. So the derivative of the outside function is stuff to the 9th power. 9 times stuff to the 8th power times derivative of stuff, yes? That would be, in this case, 6x squared plus 6. So this, if I call this, well here, let's just keep going. So that's that answer. We'll come back to the general idea in a second. Derivative of this, don't lose the 9th power. Same idea, right? Stuff to the 9th, so 9 times stuff to the 8th power times the derivative of stuff. Is that okay? Everybody with me? And then finally we get this one, which is 9 times stuff. Oops, got out of there. Oh yeah, that's fine, Jeff. We got Lazoa. I need a -2 there. There we go. To the 8th power times the derivative of stuff. Got a little messy. Now you guys see why I want you to use pencil. Every single answer basically looks like this. If I call the inside stuff, if I call this u, y prime is 9u to the 8th times, what is this? Let me do it like this, in fact. dy equals that du. Isn't this the derivative of u? Derivative of the inside, yes? This is also, oops, this one is also 9 u to the 8th. If I call this u, this is 9 stuff to the 8th times du. This is 9u to the 8th du. Yes, every single time. Every single time. Okay. You guys with me? I've made this kind of point before, but now I want to focus on different ideas for what this is. What must the antiderivative of this be? What must it be? Forget about this u shit. What is the antiderivative of 9 by 8 power 6 squared plus 7?
2x cubed plus 9.
It must be this, yes? I need you to understand. I don't care how funky the function is. If I know its derivative, that must mean I know the antiderivative of what I got. It's exactly back to where I started. You guys at all with me? So no matter how disgusting it looks, if I know the function and its derivative, I know the antiderivative of its derivative. It goes right back. I don't have to do any work. But in each case, the derivative was in this form. And what is the integral of this? What is the integral of 9u to the 8th with respect to u? You can do it. What's the, here. What's the integral of 9? Yeah, well, that's fine. 9u, x to the 8th. 9x to the 8th. What's that integral? It's nice and easy. It's beautiful. It's almost too good to believe.
The 9 over
Did the 9 just go back up? You guys see that? Yes? So for these, every single one had this form. And do you see? This integral is the same idea. What's this integral?
u to the 9.
U to plus
So when I integrate its answer that has this form, I get the form u to the 9th for every single one of these, even though the inside function was a different function. Every single one of these was a function to the 9th power. U to the 9th power. Now, if I just gave you this from out of nowhere, here. If I just gave you that from out of nowhere, which would have been funny, maybe I should have done that. And I said, find the antiderivative, you should have come up to me and just kicked me in the freaking leg and said, what the hell's your problem, man? Because that's some shit. Ain't no way I'm gonna do that. Are you kidding me? We know the answer now because this is the derivative of a function we had. So I know the answer. It's that function I took the derivative.
I mean, if you look at them both, it's easy enough to figure out that it's changeable.
Yes, this is all about chain rule.
Yeah, it's just do it reverse.
But if I look at the form of this, the form of this is 9 something to the 8th power times the derivative of that something. That's the form of each of them. So the rule we're about to get into, the method we're about to use takes advantage of the fact that if I have a function that's kind of like inside of another function, but that actually goes beyond that, but let's just start there. Then that must have come from some kind of chain rule. It just had to. So like I said earlier when I had sine of x squared something, so here. If I've got that, can anyone tell me what's missing for this to be a direct antiderivative? You can't do this. You can't do this. Why can't you just do the way it's written right now? Can anyone tell? Yeah, because if I think the answer is cosine of x squared plus 4, I'm wrong. Because its derivative has a 2x, yes? So in order to make this work, what needs to be here already? Freaking 2x. And 2x is the derivative of the inside. So, you're not going to believe this. This method is called U substitution. So if I put what's necessary here, if this is my question, so this is my question here. Here's how the method works. What was the inside function? More generally, what function in this has a derivative that's in this also? What piece of this has a derivative that is also in here? X squared plus 4, because its derivative is 2x. You guys, so more generally, because to be honest, the thing I'm going to call U does not have to be inside a damn thing. It just has to be a part whose derivative is in there also. 90% of the time it's going to be inside something. What is that? Whatever percent is going to freak you out. So I'll show you an example like that in a minute here. So here's the process. Here is the process. Find the function whose derivative is in there. Call it U. I'm going to take a total differential. What all that means is, instead of being du over dx, I'm going to multiply the dx up. What's the derivative of this side?
2x.
2x dx. So just to remind you guys, if I do du dx, that's 2x. All we're going to do is we're going to put the dx over there. Don't even write that middle part. Du is equal to 2x dx. We've done that before. So here comes the substitution part. Obviously, what do I put in place of that?
2x. U.
I put u, because that's what the shit it is, yes? Now here's the neat part. What is 2x dx? Yes, this together is du. Now look at that integral. What we have done is we've captured the form, sort of like 9u to the 8th du was the form of all three of the ones we did first. Yes, you guys are all with 9u to the 8th du, yes? That was the form of each one of them. They each had a different frickin' u, but their form was the same. So now if I just integrate sine u, what do I get? We've done sine a billion times today, I'm sorry. What's the integral of sine? Almost.
Negative cosine.
Did the problem start with u? Yeah, it was me. I did. No. So yeah, it started with x's. So I better end with x's. What was u?
Negative cosine x.
Done. Now, why does this make sense? If I take this guy's derivative, it's going to be sine of shit times derivative of shit, and there's the derivative of shit, right where it's supposed to be. If that was not there, this integral, to be honest, this one specifically would be impossible. Some integrals you can actually, in chapter 2, in Calc 2, you'll learn ways around it if the chain rule piece is missing. There's other things you could do. But sometimes if the chain rule piece is missing, you're screwed. You cannot do it. we'd have to use something called numerical methods, which is get an estimate. I don't know if are you guys all with me? So this is integration's answer to chaining. In fact, I think I pretty much say that directly. So if you look at the other side, where did I put them? Oh, here. Other side of the sheet we just did. Integration's answer to the chain rule. Blah, blah, blah. So let me do this. Let's do some more examples. I'll do more. I've given you 2 examples here. One indefinite and one definite. So let's do this. Let's do another indefinite example. Here's a good example of U does not have to be a part that's stuck somewhere. Although 97% of the time it will be. It'll be the inside, like the sign of x squared plus 4, U was x squared plus 4, it was inside. In general, it will always be the function that's in there whose derivative is in there also. So let me ask you this very weird sounding question. What is in that interval? Is there an x in that interval? Is there an x in the interval? You guys are gonna hate me. No, there is no x in the interval. There is a 1 over x in the interval. Do you guys see what I'm saying? I'm sorry. Please forgive me. But I want to make a big point of that. Because this becomes really important for U sub and for the very first thing you learn in Calc 2 in case you're going to take Calc 2. What I'm talking about right now is stupid important. This does not have an x in it. It has a 1 over x, has an ln x, and it has a dx inside, yes? Which piece of that has a derivative that is one of the other things that are in here? Ln of x, his derivative is 1 over x dx, yes? Do you guys see that? So that's why it's important to not think there's an x in there, else it would never match with the shit. There's a 1 over x in there, thank the gods. So what am I gonna let U equal?
ln x, sorry.
Yeah, U is gonna be the thing whose derivative is in there.
Right, first.
Because then when I take a derivative,
It's 1 over x.
I get the thing that's in there. So what is my whole point with U substitution? I'm given an integral with x's. Right, it's got functions of x all over the damn place. I want to convert all of that to functions of U. Right? If I can replace all my x stuff with U stuff, then I can integrate that new integral and then bring the x stuff back. So I'm kind of like uncovering the real form this is in. Sort of like we just did a minute ago, that was 9u to the 8th du. That was the form all of them were in. What's du now?
1 over x times dx.
1 over x dx. So if I break this up, how can I rewrite this? ln x is, no,
U,
ln x is u. And what's 1 over x dx?
du.
du. U du. If you have any x's left, number 1, you've made a mistake, and number 2, you cannot go forward. This integral sees u as a variable. X is a funky ass associated variable. It cannot work with directly. If you have any x's left over, you've made a mistake. Now you let go of wherever the hell. What's going to be beautiful is for a lot of problems, once you identify what u is and you do this, your new integral is going to be this really nice, compact, awesome thing. Forget all the shit for a moment that gave. What is the integral of u? U squared over 2. Is that all right? Forget where it came from. You were just looking at integral of u. That's all that matters right now. And the integral of u to u is 1/2 u squared. Did I start with u? Nope. I started with x's. So what's u? What was u? I get the answer in terms of u, and then I told myself here what u was, so then I could just put it right back in.
When you're writing, do you still have to put the absolute value thing?
No. Because let me see. I did not take the integral of 1 over u or something, right? The ln x I was given didn't have an absolute value in it, so I can't change it. Yeah. It's only if I have 1 over x whose domain is everything except 0, natural log of x has the absolute value, so the domain is the same. That didn't happen here. Yeah, the function they gave me was natural log, not absolute value of x. Yeah. Good question. Good question. Yes.
Can you explain again why you chose ln x to be u?
Because its derivative is also in the integral. So I could have let u equal ln x, or I could let u equal 1 over x. That was really the only two things I had. Does that make sense? What do I have in there? I have an ln x, and I have a 1 over x. If I let u equal 1 over x, its derivative is negative 1 over x squared. That ain't telling me more shit. Yes? So what do I always make u? I make u the function whose derivative is in there also. Because then, what does that lead to? What am I trying to do? I'm trying to replace all the x shit with u shit. So whatever du is, I want it to be in there so I can replace it with du. That's why I let u equal the function whose derivative is in there. That will make this step actually work. Maybe? Screw you, Jeff? Okay. Here, let's try a few quick fire ones. Hold on. What about, what you got, Jeff? Let's do this one.
Is
Very
that
good.
x to the third square root
Yes.
7?
Yes. Not cube root, square root, yeah. Do you see a function whose derivative is in there also? And real quick, I do not give a shit about constants, and you'll see exactly why here in a minute, so don't worry about the constants. Do you see a function whose derivative is in there? Maybe it's missing a constant, who cares? Yeah, the inside is basically x to the 4th, yes? 7 is going to die when I take a derivative, correct? So it's blah, 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 x to the 4th. What's the derivative of that? Blah, blah, x cubed. So the derivative of the inside of the radical is outside. It's x cubed outside, yes. Can I put the x cubed with the dx? Could I just move those? Could I move it over? Yes. It is ready to be du. So watch. Could I rewrite this like this? Have I changed anything besides the way it looks? No, these are the same function, yes? So this is free to move, which is another reason why I want this to be du, which means this must be u. So what happens if I let u equal this? What is du?
Negative 8x cubed.
Yes, negative 8. Is that cool? The 7 dies. 4 comes down. Dx. Do not forget your dx. Let me stop for a minute. Do you guys see, do you agree with me that inside the radical is blah blah x to the 4th? Do you agree with me that outside the radical is x cubed? Do you agree with me that the derivative of blah blah x to the 4th is blah blah x cubed? So I've got a function in there whose derivative is also in there. So the whole idea of u sub is, if I let u equal the thing whose derivative is in there, and then I take its derivative, I'm guaranteed it's in there. So then I can replace all the x shit with u shit. So what do I put in place of 7 minus 2x to the 4th? Me? Yes, you. Are you guys okay if can I do this at the same time?
Yes.
Is that okay? It'll be the square root of u, which is u to the 1/2. And what is all this? Almost this, yes? What am I missing to make it this? No, okay. Yeah, I'm with you, We will.
3x.
There is a major disagreement between my colleagues and I. They're wrong, but it's okay. It is infinitely better. It just is, because if you don't do it this way, you will make mistakes. You will think you could do some integrals when you can't. What did I say you could put into and out of an interval? Constants. If I multiply something by 1/2 and then I multiply it by 2, then I change it. Right? If I cut something in half and then I double it, isn't it right back to where it was? You guys agree? Okay. So if I want a -8 to show up right here, look at me, just write it. Look at me, just write it. That's illegal what I just did, correct? I have changed the problem. I'm not allowed to do it. Well, if anybody here is me, but I'm not even allowed to do that shit. At the same time, if I multiply by -8, I better divide by -8. So overall, what did I just do? -8 over -8, I multiplied it by 1. So what you do is, if you're missing a constant that you need, you just multiply by the constant inside, divide by it outside.
Not mess with the other ones with the square root.
It's all one thing. It's all one term. Yes? So, let me write this again. This is getting a little messy here. Hold on. I'm just gonna write everything I just had. Don't give up on me. Hold on. I gave up on you a long time ago. Be quiet. You write this like this right now. I'll do one little change. Alright, that's what I did first, yes? You with me? This is all one term, yes? So watch. If I multiply, are you guys, if I do this, have I done shit? Have I done a damn thing? I haven't done shit here, yes? Right? If I went to my boss, I'm like, boss, I want more money. And they're like, okay, I'll tell you what, I'll double it and cut it in half. There you go, man, go with it. So you multiply by 2 over 2. You did nothing for me, thanks. You guys with me? What am I allowed to bring in? And is everybody really cool with that? I could have put 18 billion over 18 billion outside. Whoop-de-doo, right? Didn't do. Good job, Jeff. Couldn't I take that top -8 inside? Because I'm allowed to take whatever the shit constant into or out of an interval that I want to. Is that... So I could put outside the interval, I could put whatever ratio that's 1 that I want to. There's only one ratio that's going to help me, because what number did we figure out that we wanted to show up? I want -8 to show up, so that's why I chose -8 over -8. This one I can do what? I can bring this one in, yes? Oops. Whee. That factor in -8 just comes in. So yeah, and then the negative, and then the 1 over -8 is still out here. So all I did was I took the top one in. Now, real quickly, guys, just in case this is the issue, can you guys tell me what 5 times 11 times 2 is? What's the smart way to do that? What's the smart way to do that? 5 times 2 is times 11, right? So if I take this and I put it to there, that doesn't change shit. So what's the only operation in this whole string of things? If I just look at the functional parts, they're all multiplying, correct? So that, I can take that -8 that's timesing this whole thing, I can put it wherever the shit I want to inside. Of course I can. If all I have is multiplication, I can multiply any 2 elements of that whenever the hell I want to. Of course I can. I don't know if that's part of the problem. So of course I can bring that -8 in wherever I want to in the mix. So of course I'm going to put it next to x cubed so then I can see my du. Can I see my du now? Okay. Is this, ignoring this for a second, is this whole thing being multiplied by -8? Yes. Is it still being multiplied by -8? Okay, same shit. But now what can I do? What is this? Du. What's this? Do that. Isn't that a much better? Doesn't that look infinitely better than this? Do you not agree? Which one's better? This integral or this integral? You're all like, this one. Okay, sorry. I didn't make it distinguishable. So real quick. If there was a negative 8 here, do you all agree with me that this would be the derivative of this? If there was a negative 8 right there, yes? So this is in the form square root of stuff times derivative of stuff. It is. I was just missing a number to make it work directly. So I gave myself that number by multiplying by it and dividing by it at the same time. That's what makes it legal. I can multiply the inside by whatever the shit I want to, as long as I divide the outside by it at the same time. Or vice versa. Is this integral easy? Come on, you can do this integral. What's the integral of u to the 1/2? U to the 3/2 times 2/3. And what was u? Oh, I can do this. You can do this, Jeff.
7
What was u?
7 minus.
Oh, that's what it is. I can barely see now. Ah. What was u?
7 minus 2 is
Yes, 7 minus 2x to the 4th. That's the very first thing you told yourself. When I take this guy's derivative, am I not going to get an x cubed? When I take this guy's derivative, am I going to get an x cubed?
Yes.
You're going to get negative 8x, but am I going to get an x cubed? Yes. That's why the fact there was an x cubed out front told me u sub will work. There's a function inside. There's a function in the integral whose derivative is in there also. U sub will work. I might need a constant that I'm missing, but who gives a shit? Because I can always make any number I want to ship. If I needed a 38 inside, I would have a 1/38 outside. That balances out. I didn't do a damn thing. I just made the inside doable now. Yes.
Can you explain again how you came up with this?
Are you cool with how I came up with u?
Yeah.
Oh, so then d is just its derivative. That's all. What's the derivative of 7? 0. What's the derivative of negative 2x to the 4th? Negative 8x cubed. And that would be like du dx, and we just multiply the x up. And now you see why I'm going to see shit dx, and I want to replace it with du. So then I have an integral that's just in terms of u. So the whole idea of u sub is, I start with craziness with x. Can I consolidate some of that craziness? If I identify a u, and du is the other part of the shit, maybe I can make that big ass integral with x's in it become this nice little integral with only u's in it. Because the very first thing we did before we, where is that, Jeff? There it is. All this shit here, all this shit we did earlier. Every single one of these, do you all agree with me? They're very different functions. Do you agree with me? These are very different functions. But their derivatives all look like this. And they all look like u to the 9th. So that's why, here, you can do it, Jeff. Can you? All right, you guys remember this. Remember this, okay. Remember that, remember that, remember that. Can you do it, Jeff? We'll find out. We'll find out. Yes, I can. What if I had this? Oh boy. Yeah. Is everybody with me? Is everybody with me? This is a new problem. Brand new problem. Does anybody see a function in there whose derivative is also Do it again.
The inside of the root.
Yes, the inside of the root,
Inside.
yes.
Yes.
6 minus 8 sine x. So like I said, 90-something% of the time, what you want to let u equal is going to be stuck inside. It's going to be exactly the same as chain rule. It's going to be the part that's inside of another function. Some of the time it's not going to be. It's just going to be the function whose derivative is in there. So if I let u equal this business, what is du?
Cos-
Negative 8 cosine x. dx.
So everybody see that so far? So what am I missing? So I see this. Do you see this? I do. There it is. Yay. Do I see this?
Yes,
Almost.
missing.
I almost see that. Yes? I need you guys to be with me on this. I want to replace each thing in my current integral. I want to replace it with something to do with u instead. Because then what I'm doing is I'm uncovering the form this is in. And it's so much easier to integrate that. I'll show you another example of u sub with a more basic idea than not integration. Maybe that'll help too. Okay. So what am I missing exactly?
Negative 8.
-8. Now we know how to make that show up. I wish there was a -8 in front of the cosine, don't I? I wish there was a -8 right there. Because then I would have -8 cosine x dx and that would be du, yes? How do I make a -8 show up here? Well, I write it there. Hey, but at the same time I better
Put it on one.
divide by it, yes? So this becomes -1/8. This is what?
U,
What is -8 cosine x dx?
du.
D. That's what tells me I can go forward. I was able to create this, so that tells me I can go forward. And then what's this?
U.
U to the 1/2.
U to the 1/2. Now, real quick. Same form. Same form, because these are both the same stupid thing. These are both the same thing. Now, real quick. You guys might see what I mean, but do you see how it's really easy to believe Jeff has gone insane? Are these the same thing? No, but do you know what I mean when they say they're the same thing? Aren't they both? Don't they both have a function inside of a radical whose derivative is outside? Don't they both have a function inside of a radical whose derivative is outside? That's what they both are. They're both the same integral. They just have different details inside. Who gives a shit? How do I take the derivative of anything to the 9th power? 9 times that thing to the 8th power times the derivative of that thing. Do I give a shit what's inside? I will if I want the answer, but the very first step, I don't give a shit what's inside. It is always the same. That's why this works. I'm trying to uncover what is the basic form. If I integrate the form, I can put the details back in. So my answer is not going to be the same. Because these two situations, do they have different u functions? Shit, yeah. Completely different u functions. But does everybody agree this integral is exactly the same? Because they had the same form. When I do the u sub, I uncover that form. That looks horrendous as shit. That looks easy as shit. How do I integrate this? The same way we just did, Jeff. Good point. Then I simplify it again, and then I bring my u back. In this case, my u was that. You forgot your glasses again. All right, that's okay. I think I got it right. Yes. So from a purely like nuts and bolts perspective, let me show you this. It's on that handout. No, it's not. Let's do this real quick. So everybody got that? Okay. can you integrate this here? Yes. I'll just tell you. We could totally integrate this. Can you integrate this here? If I took that guy's derivative instead, what would it entail? What would it entail to take this guy's derivative? Would it entail chain rule?
Yeah.
Yeah. And this guy would too, but do you agree it's just a constant? What's this guy's derivative? Is it just a constant? No. Can I integrate? So this is not possible at all. Could I integrate this guy? Totally, because I have a function inside, which 90% of the time is a function inside of something whose derivative is in there also. That's when U sub will work. I definitely sure as all hell can't integrate this directly, yes? That very first one, I could integrate directly. Integral of secant squared is tangent. I have to divide by 5 to kill the 5, I'm done, right? I could integrate that one directly, because all it's missing is a number. This one is missing a function, I can't do it. This one has the derivative of the inside in it, which means it is the form of a chain rule, so I should be able to undo it. Maybe. So here, let's take a look. Oh, let's do, okay. So now that you guys don't feel comfortable yet, let's try a definite integral using U substitution. We're gonna do E? Sure, why not, Jeff? This is definitely not like a direct antiderivative, ain't no way in hell. Why would I know U sub will work? Yes, the derivative, yeah, the inside function 3x squared minus 1. There's a function in there whose derivative is in there also. Now, what is the derivative of 3x squared minus 1? 6x. Is there a 6x in there? No. The x is in there, so it's the function part I need, because any number I'm missing, I could just make that show up. Because we invented freaking numbers, we do that shit. If I'm missing a functional piece, I'm screwed. So for example, real quick, we will do this problem. I just want to put next to it. This is impossible for us. This here is completely impossible for us. And to be completely honest with you, it is impossible, period, to do this by hand. What tells you that? What's missing here? There's no x here. So I'm asking, like I really want, so help me out, guys. What's the derivative of e to the 3x squared minus 1? What is this guy's derivative? It's itself times 6x. So this, the integral of this is that. It's easy, right? So this is asking me, okay, I want you to integrate something that's missing the x piece that would have to be there for this to work as directly, right? So there are going to be some functions that are missing something that in I keep calling it chapter 2. In Calc 2, you'll be able to kind of like finagle your way around it. This is an example of a function that if I'm missing that, I am screwed. There's not a damn thing. Calc 2, you'll learn an interesting thing you can do by hand to estimate this. Numerical methods, you would learn a method to do this numerically. Okay. So that's impossible. Get out of our face. You look gross. All right. You're fine, but you're gross. So somebody help me out. Which piece do I let equal u? What's u equal to? 3x squared minus 1. 3x squared minus 1. So u can be stuck somewhere. That's the part that can be stuck somewhere. What's du? 6x dx. I currently have what number in there? I have a 4 currently in there. I want it to be a 6. Yes? Any suggestions?
I find it easier from the DU just by the 6.
I know. I get you, Paula. I'm trying to save everybody from making really simple mistakes. And I've seen you divide by 6, which is better than what I see other people doing. Other people divide by 6x. Just to address this, because I know you're going to have tutors, you're going to have teachers in the CISL that try to make you do it this way. There's a method where you solve for dx and then you replace dx with what you solve for. All right. The problem is, couldn't I do that here? Watch. Didn't we already say this is impossible? Didn't we already say this is impossible to do? If I let u equal 3x squared minus 1, du is 6x dx. If I divide by 6x, I solve for dx. And then I plug this shit in here, and then I have students that actually do it. You're completely wrong, so let me show you. So this will become, we'll talk about I don't care right now about those. This will be 4e to the u times du over 6x. And then I either have them integrate and ignore this, or this somehow all comes out. Am I allowed to take that out? Of course not. Do you see what I mean? That's what leads people to shit. And that's what kills me about this. You're going to have teachers that tell you this. You're going to have tutors that tell you this. And then it feels nice. You can solve for dx and plug it in for dx. Ooh, but then you start doing all kinds of horrible shit. I'm trying to save you from that. And I'm always open to the idea that maybe I'm the one. Maybe I'm insane. That is so true sometimes. So this method gets you practice with the idea of balancing things in mathematics, which actually shows up quite a few times. I want to balance, I need a 6 inside. I currently have a 4, so the easiest way to do this is take the 4 out the way, divide by 6 on the outside, multiply by 6 on the inside. Yes? So if I take the 4 out, divide by 6, multiply by 6, now I've got my du inside, yes? And I have not done a damn thing to the value of this. I've made it look different, but that integral is the same as that integral, yes? Okay. Now, I'm not sure. We'll see. We'll see how this goes. So this will be 2/3. Leave these off for a minute. 6x dx is what? Du. And this will be e to the what? Because that's what we made u equal, yes? Look at that beautiful integral. Are you kidding me? Now here's the problem. Okay, here's the huge trouble. Please, I'm sorry that was so quick, but I don't want to spend time on that because it does lead to insanity. The way you do it is much better, but I'm going to see people do it the other way, which sucks. If you just do numbers, you're fine. What do these numbers mean exactly? What are 2 and 3? What do they mean? They're the endpoints for what, though? The ends of what? Good. On the x-axis, correct? They are what x is doing. X is starting at 2 and ending at 3, and I want to know the area from there. You with me? The way we've rewritten this, what's our variable now? U is our variable now. Yes? I need to know what the shit U is doing now. So this is an integral with respect to x. So the numbers all relate to what x is doing. I have an integral with respect to u now, yes? I need to know what the shit u is doing. So how the hell do I do that? Well, I established a connection between u and x here, right there. When x is 2, what's u?
4, 12.
11, right? 4, 3, 12, minus 1, 11. So when x starts at 2, u starts at 11. When x is 3, 26. So remember I said, for u sub to work, I have to be able to take everything related to x, all the x stuff, and I have to replace it with u stuff. The definite integral, the numbers are what the variable is doing. It started with an x variable, I made it a u variable, I better frickin' tell myself what the shit u is doing, yes? Now how do you integrate e to the u to u? Okay, so much answer. I need you to understand, we took this integral, this, look at this, just gaze on this, and we realized, oh, it's basically this. All this other shit around it is all wrapped up in here, yes? So I've just reorganized my integral into a much nicer form. So the integral of e to the u is e to the u, so I get 2/3 e to the u, and what's u doing going from 11 to 26? So now I get 2/3 e to the 26 minus 2/3 e to the 11. Right, just plug the 11 and the 26 in, right? F, big ass F of B minus big ass F of A. And I don't care what number this is. This number's huge. Who cares? It's a big old number. So I did promise you one thing. I want to do it right now. Let me let you guys finish catching that. And Paola, if you want to keep doing that, you can. It sounds like you might have a decent handle on how to be careful about it, but when I'm first teaching, I hate doing it that way because it just opens the door to so much misunderstanding.
It's easier to see it a little bit different.
Yeah, I'm with you. But like I said, sometimes I'll teach things that I know will help later. And this idea of like balancing stuff, it will help so much in a lot of different little areas in mathematics. Okay, so here's what I was going to do. Do you guys remember, real quick, who remembers how to factor this? Oh, let me do this. Let me do it easier. How do I factor this?
X plus 2 is next.
Right? That's a fantastic little difference of squares, yes? You with me? Alright, so what if I had this? Do you see how that also is a difference of squares? How many terms are there? 2. Are they both perfect squares? Yes. Am I subtracting them? Yes. If I let this equal u, and I let this equal v, what is u squared minus v squared? How do I factor that?
U plus V minus
Yes, u plus v, u minus v. And now I just take this and put it there, and I take this and I put it there. So I uncover the form it's in. This is in the form difference of squares. It's just hard to see because there's so much shit going on. If I call that piece u and that piece v, I can focus on the form it is in. So when I factor the form, and then the last thing, just like when we did the integral, the u sub, I bring back what each thing is, yes? And then I can simplify that inside. I'm not going to finish that. I don't care. I don't know if anybody's ever seen this for factoring, this idea of substitution for factoring. It just makes it easier to look at in the middle of the problem. This is the middle of the problem. The beginning had x's and y's. The end will have x's and y's. The middle, I just made it look better for myself. That is essentially what u sub is doing. Maybe. Screen Jeff. And just to show you, we did a problem earlier. I can't remember exactly what it was, but I think at one point we did this, something like that. And we did it without u sub. But couldn't I let u equal 11x? What would du be?
11.
Do I have an 11 dx? Nope. So if I put 11 here, so now I've got an 11 dx, yes? That would be du e to the u, and u was Jeff. We did that earlier without u sub. But just to show you, if you want to use USub, you can. But dear God, if the inside function is linear, you do not need to do USub. You can if you want to. And I understand if some of you guys have never seen USub before, you're like, I am not going to use this shit anymore than I have to. Thank you. Fantastic. That's an awesome way to be. I love that shit. You don't need USub for that kind of problem. That's the one we did earlier where the answer can't be e to the 11x because there was no 11. So then I divide by 11 to kill it when it tries to come out. A very violent math, I'm sorry. So the last week and a half has been incredibly crucial. Establishing areas are related to antiderivatives is the biggest step in calc, period. Huge. I don't know if I made that a big enough deal. I think I did. And then this USub thing just opens the door. We can immediately do so many more intervals of things. Oh, have I said this yet? I did. What's happening next week? Quizzes, yes. Two quizzes, yeah. Monday and Wednesday we have quizzes. Monday 4951, Wednesday 5253.
So these won't be on the quiz.
Hell no. So next time I'm going to show you, we'll do some more practice with USub. I'll show you some more flexibility with USub. And then we'll get into chapter 6, because we're crazy.
So estimating under the curve.
What's that?
Anti-derivatives and estimating under the curve. Summation for 5.
Well, that was 5. Oh, I see what you mean. Yeah.
For the
5-1 was like using 6 rectangles.
yeah.
Left endpoint, right
So
endpoint.
just
Yeah.
like estimation.